How you doing? I'm your man, John Wilson. I lost my hearing last time, so I'm going to scream through the entire video. Today, we finish up Module 8. We're going to do 8.4 and 8.5. Specifically, we're going to learn how to solve systems of equations through elimination, and we're going to work with special systems. Last time we were here, we were solving systems that required us to either A, identify the inverse coefficients, or B, create the inverse coefficients by multiplying an equation by -1. Once again, in a perfect world, that'd be all we have to do, but unfortunately that's not the case. There will be times where we do not have inverse coefficients. There will be times where we don't even have the same coefficients. We can still go in and create the inverse. It's just going to require a little math. So we look at this first system right here. We have 2x plus 10y equals 2, 3x minus 5y equals -17. First question. Should always ask yourself, is that in standard form, both equations, yes or no?
Yes.
Yes. X term, y term equals sign constant, x term, y term equals sign constant. The next thing you do is you look for inverse coefficients. Do I have inverse coefficients there anywhere? No. Do I have same term coefficients anywhere?
No.
No, I don't. I don't have either, but what I can do is try to find the multiples of the coefficients to see if any of these numbers are divisible. So I look at the x's first. Which one of these x's is smaller? 2. So ask yourself this question. Does 2 go into 3 evenly with no remainder? Yes or no?
No.
No. So I'm still trying to find the easiest way to solve the problem. So I go to the y's now. Looking at the y's, which one's smaller? 5. Does the 5 go into the 10 evenly with no remainder?
Yes.
Yes. How many times can 5 go into 10? 2. So what we can do here is we can multiply this equation, the one with the smaller y value, in order to create the inverses. Now this is a positive 10. Right? Positive 10y. What's the inverse of a positive 10y? Negative 10y. So, what should I multiply the bottom equation by?
-2.
Not -2. -2 would make it positive. I want a -10. What do I need?
Positive.
Positive 2. So I will take the bottom equation and I will multiply the bottom equation by -2. I can do that just like multiplying by -1. I can multiply the equation by anything I want to create my inverse. Just remember, you have to multiply every single term by that integer. Did I do something wrong here? Yes or no?
It's a
What did I
negative.
do?
It's a negative.
I wrote negative. Good. People are paying attention. It's not -2. It's +2. Remember, you're trying to create the inverse. Did anything happen to the top equation? Yes or no?
No.
No. So we'll just rewrite the top equation. 2x plus 10y equals 2. The bottom equation, you need to be writing. The bottom equation, I multiply every single term by 2. What is 2 times 3x? 6x. What is 2 times -5y?
-10.
-10y. That's what I was looking to create. I have my inverses right here now. I'm just going to finish up the multiplication. Equal sign. 2 times -17 is what?
-34.
-34. Perfect. Now that I have both of my inverses, I am going to just we'll just leave it there. This is all connected now. All right, what I'm going to do now is I'm going to solve this equation. The first thing I have to do is I have to go in and cancel out the what? What am I going to cancel out? The y's. So let me rewrite this over here so I can actually go in and give myself some space to work. 2x plus 10y is equal to 2, and then 6x minus 10y is equal to -34. So I work from left to right. The y's cancel out. That's what I was looking for, my inverse coefficients. Then I combine the terms I have left. I have a positive 2x and a positive 6x. What does that become? I want you to delete that out of your head. We're not multiplying, it's just positive and positive. We combine them, we're adding them together. That gives me a what? 8x. Gives me an 8x equals, you have a positive 2 and a -34. So 2 minus 34 is, anybody? -32. -32. That's exactly what you should get. Think about it this way. You owe me $34. -34, right? If you pay me back $2, what do you still owe me? 32. You owe it to me, so it's going to be -32. You get to this point, what's up? You have a question?
My question is, where did you get to?
Here's what I did. I looked at the x's. I asked myself, does 2 go into 3 evenly? Yes or no? No. I looked at the y's. Does 5 go into 10 evenly? Yes or no? Yes. So I want to make these two my inverses. What can I multiply negative 5 by to make it an inverse of a positive 10? 2. I can get the 2 from anywhere. I can multiply this equation by anything I want. As long as I multiply every term by that value, it doesn't change anything. But what it does do is give me my inverses. So if I multiply negative 5y by 2, it gives me the inverse I was looking for. And I have a positive 10 and a negative 10. Isn't that what we're looking for every single time? All right? We're looking to create inverse coefficients so I can eliminate one variable in order to solve for the other variable. You with me? You understand how we got it now? We can pick any number we want. The goal is to create the inverse. I am now here. I have 8x equals negative 32. What's up?
I have a question.
Okay.
For the bottom one, if I were to wanna like plug in the x for a 3 instead of the 2, like for the next step,
What's plugging in?
like
Substituting? Okay.
if I were to want to substitute the number that we for the next step, can I use the one that we already did that we multiplied the 2 by, or is
No. Good question. No, you can only use the original equations. Only the original ones. You must use the original equations, either this one or this one. Use one of those original equations, substitute it in, and solve from there. Okay? All right, so we get here. We're going to divide both sides by what, Chris? We're here, right here. What do I divide both sides by? Okay, Chris, we have 8x equals negative 32. I'm trying to get x alone. What's happening between the 8 and the x? Chris, what's happening between the 8 and the x? What operation's happening here? Now, what specific operation is happening between 8 and x? Anybody want to help them out? What's happening? Anybody?
Multiplication.
Multiplication. What's the inverse of that? Division. So we're going to divide both sides by
8.
8. 8 and 8. That cancels. We get x is equal to negative 4. We have half the answer. Negative 4 is my x. I need to go back now and I need to find the what? Y. Make sure you go back and you use one of the original equations. Which one looks easier to work with?
Top one.
Top one. So we write the top one. 2x plus 10y equals 2. I know what x is. I know that this is multiplication happening here. So I'm going to write my 2. And then after the 2, what am I going to write in the last field? What comes after the 2?
2 times
How-
2 times negative.
Okay, so how do we indicate that? With what? By using, not that. What are these?
Oh.
Parentheses. So it's 2, parentheses, negative 4 plus 10y is equal to 2. I do the multiplication here. What's 2 times negative 4, class? Negative 8 plus 10y is equal to 2. I add 8 to both sides. I do that to get the 10y alone. Those cancel. I get 10y is equal to 10. I'm going to divide both sides by 10. And that will give me the y value. Y is equal to 1. So my solution set is negative 4, comma 1. That's it. The only thing that changed here is we now had to go and do just a little quick mental math and see what here was divisible by the other value. Any questions on this first one, on any step along the way? There's just one more type of system that we have to solve here. It's what happens if neither of the numbers are divisible by each other. There is a way to get to that solution. But any questions on this one? Any questions? What's up?
Is it lowest common LCM?
LCM is least common multiple, yeah. Now you don't always have to find the LCM, as you're going to see when we get here. Sometimes you can just find the CM, a common multiple. That works as well. Least common is just easier. So, we're on this problem right now. You got a question?
Yeah.
What's up?
For like, it's a positive 10 and a negative 5y. So, would you just disregard if it was possible, a positive and negative, or would
It has to be a positive and a negative. If this was a positive, if this is a positive 10, and you're trying to create the inverse, you have to multiply this by whatever number to make it the inverse of positive 10. What's the inverse of positive 10?
negative?
Negative 10. So the only number we can multiply negative 5 by in order to get negative 10 is positive 2.
Okay.
Yeah, so it's a little quick mental math. They're usually small numbers, but that's it. You're always, now if this was a positive, let's just say, you don't need to write this, if this was a positive 5y, what would I then have to multiply the bottom equation by?
-2.
-2, because I'm trying to make the inverse, okay? So let's try this example now. We have 2x minus 3y equals 4, and 3x minus 4y equals 5. When I go through the x's and the y's here, I'm going to run into a small problem. Eyes up here, please. If I look at the x's, I go to the smaller one. Does 2 go into 3 evenly? Yes or no? It does not. It does not go in evenly. Does 3 go into 4 evenly with no remainder? Yes or no? No. So therefore, when I run into this problem, I have to go back to elementary and find something known as the LCM. What's the LCM? Least common multiple. When I'm finding the least common multiple, then if I run into this situation, it doesn't really matter which variable I work with first, the x's or the y's. Here's what you do. You look at the x variable. I have a 2 and I have a 3. Can anybody tell me what the least common multiple of 2 and 3 is? What is it? 6. And in case you're ever struggling to find the LCM, just do this. What's 2 times 3? 6. That's not always going to give you the LCM, but at the very least it will give you a common multiple. I'm going to show you what we did with this. In this case, the LCM is 6. What about 3 and 4? What's the LCM? 12. So we have 2 options here, guys. We can either turn the x's into inverses at 6, or we can turn the y's into inverses at 12. What do you guys want to do? You want to deal with the x's or the y's?
Yes.
The x's?
Y's.
Who says x's? Raise your hand. A couple people. Who says y's? The y's have it. Okay. So what we're going to do is we're going to create inverses with the y's. Now, it makes it easier if you try in this situation to make the top one your positive and the bottom one your negative. So the question then is this. I'm looking at negative 3y. What can I multiply negative 3 by to get a positive 12? Shimon? I want a positive 12 on top. What can I multiply negative 3 by to get a positive 12? Negative 4. So I'm going to multiply the top equation by negative 4. Now, if I have a positive 12 on the top, what do I need on the bottom? What do I need on the bottom, class? Negative 12. So what can I multiply negative 4 by to make it negative 12? Not negative 3. 2 negatives make it positive. Positive 3. There we go. So I have to multiply. This is the only circumstance where both equations would have to be multiplied. So we'll go in. We'll do all this multiplication. This is as hard as systems of equations get at this level, when you have to multiply both equations. You will run into this. Yeah, that's just, that's an errant line that just developed due to my interaction with the board. So we do the multiplication. Please don't forget to multiply every single term. Negative 4 times 2x gives me? Negative 8x. Negative 4 times negative 3y gives me? Positive 12y equals. Negative 4 times 4 gives me? Negative 16. This is where you have to be oh so careful with all your signs and symbols. 3 times 3x gives me? 9x. 3 times negative 4y gives me? Negative 12y. And 3 times 5 gives me? 15. Boom. I have now created my inverse for y. Once I've created my inverse, let me just go in. We're going to rewrite this over there. Edit, copy, edit, paste. Let's just take this. Okay. I'm just going to drag it over so I don't have to rewrite the whole thing. You guys rewrite it for me real quick over there. And then we're going to go in and we're going to start canceling out and solve. Some people already did. Okay. Once you're done rewriting, eyes up here so that we can work through this problem. People still writing. Totally fine. Key to organization. X's on top of X's, Y's on top of Y's, constants on top of constants. Make sure they're in the correct form. What's up?
You know how you made it into negative 8 plus 12y? Do you, when you are substituting the back in, do you still use the original one?
It's the same thing that Sydney asked. I would never use these equations. I always use the original ones, the ones that I started with. Always use those when you're substituting back in, okay? So here, first things first, what can I cancel out? Cancel out the y's. Positive 12y, negative 1. These cancel. Negative 8x and a positive 9x give me 1x or just
X.
x. So x equals, what is negative 16 plus 15? Negative 1. So we got half the answer. Negative 1, comma. Now that I know what x is, I need to go back and I need to find the y. So I go back to the original equation. I'm going to pick one. Both of my y's are negative here, so there's no easy way. I just pick one at this point. What do you guys want to work with, top or bottom? Top. All right, so we're going to have 2x minus 3y equals 4, and we know what x is, so we substitute it in. 2 times negative 1 minus 3y equals 4. Form the multiplication, I get negative 2 minus 3y equals 4. Pause there so you guys can catch up. Once I get to this point, Mr. Cartwright, what do I have to do to solve for y?
Yeah, right line, then you add 2 to 2.
Good, I add 2 to 2, and I add 2
to 4.
to 4. Good, I'm trying to get the negative 3y alone. These cancel, I have negative 3y is equal to 6. I divide both sides by negative 3. I found my y is equal to negative 2. My answer is negative 1, comma, negative 2. That is my solution. Any questions on this? Any questions? What's up?
So, how come you use the original marker one?
Because if we substituted one of the ones that we multiplied, we would get an incorrect solution. We always use the original equations. All right? What's up? There's 2 whiteboards, so we don't know them. Now remember, same thing I said, if you finish before other people, start doing the extra practice, or help somebody around you if I can't get to it. 4, 3, 2, 1 on this. We're going to be doing 2 whiteboards. When everyone's done with the first one, we go on to the second. All right. This looks like under the word problem domain. Nothing changes here. The only difference is now we have a scenario, and we're going to have to go in and create our system. So who wants to read this for me? All right, Connor, you got his hand up.
The Simon family attended a concert and visited an art museum. Concert tickets were $24.75 for adults and $16 for children, for a total cost of $138.25. Museum tickets were $8.25 for adults and $4.50 for children, for a total cost of $42.75. How many adults and how many children are in the Simon family?
Okay, so we have the Simon family. They went to a concert. They also went to a museum. There's a couple members of their family. We want to know how many adults they have and how many children they have. The way we do that is we write a system. Looking at the scenario, they went to 2 different places. They bought adult tickets in both places. They bought children's tickets in both places. We can assign variables to adults and variables to children. We want to let adults be what? What do you want to let adults be? X. So adults are going to be X and children will be Y. We will then go in and write a system for each venue. 1 for the concert, 1 for the museum. So first and foremost, I want to write an equation for the concert tickets. Rudy, can you tell me what that equation is?
Okay, so it'll be the concert. Okay, so 24.75x.
Okay.
Plus $16 y equals 138.25.
Equals 138.25. Good. So 24.75x plus 16y equals 138.25. There's an 8 there. Once I have that, I need to go and write an equation for the museum. Mr. Santana, what do you got for the museum?
8.25x.
Okay, 8.25x
plus
4.50. 4.5y is equal to
42.75.
42.75. All right, so once I have the system written, I then have to go in and have to look at my coefficients to see if I have any multiples. So So I look at the x's first, and I ask myself, okay, which one of these is smaller, 24.75 or 8.25? 8.25. Does 8.25 go into 24.75 evenly, yes or no?
Yes.
Yes, how many times?
3.
3 times. Okay, so I know that I'm going to have to multiply the equation by the bottom equation by something. This is a positive 24.75. What do I need on the bottom? A negative 24.75. What can I multiply 8.25 by to make it negative 24.75? Negative 3. So I'll multiply the whole bottom equation by negative 3. Notice that the top equation did not change, so I'm just going to rewrite this as 24.75x plus 16y is equal to 138.25. I do the multiplication on the bottom. That gives me a negative 24.75x. Bam! Inverse coefficients have been created. Multiply the y, that's going to give me a negative 13.5y is equal to negative 128.25. That is a negative there. Equal sign. Let me go ahead and fix this one. It's looking like a little mess. Fix it here. Go in. Write our little equal sign, and that is going to be still. Oh my God. This is what happens when you gotta write so small. Boom, boom. That's a negative. So you have 24.75x plus 16y equals 138.25. On the bottom, that is a 6. That's part of the original equation that we wrote here. On the bottom, we have negative 24.75y. I know that, it's a little messy. Minus 13.5y is equal to negative 128.25. Let me rewrite it over here so you can see exactly what we are working with. Write the whole thing. 24.75x plus 16y is equal to 138.25. On the bottom we have a negative 24.75x minus 13.5y is equal to 128.25. Rewrite that for me.
It's
Negative
negative
128.
Negative, there we go. Someone's watching. Negative 128.25. Okay, so we go in and we eliminate the x's. We combine the y's to get 2.5y. When I combine these, I get 10. And it looks so much simpler now. What do I have to divide both sides by to get y? 2.5. 2.5. I divide both sides by 2.5, and I have half the answer. Y is going to equal, what's y going to equal? 4. So that's half the answer. I'll put that there. I need to go back now and I need to find my x. So I go to the original equations before I manipulated them. And I am going to identify one of these equations to substitute y equals 4 back into. Which one do you want to use, Vivian? Bottom or top? Bottom. Bottom is easier. So we'll substitute this into the bottom equation. We'll see if we can figure out what x is. I'm going to have 8.25x plus 4.5 parentheses 4, because I'm substituting in y equals 4, and that's going to equal 42.75. I bring down the 8.25x plus, when I do the multiplication, what do I get? 18, good job. That equals 42.75. I now must get this term alone. So I subtract 18 from both sides. I get 8.25x is equal to 24.75. We're getting there. I divide both sides by the coefficient, and I'm going to end up with a nice, beautiful, clean whole number, because we're talking about a person. You can't have 3.2 people. You've got to have a whole number. X is equal to, anybody? 3. So my solution is 3, 4.
Is that 24.75 or 25?
24.75. And that is my solution. I'll show her. Write that in, look over what you wrote, and tell me if you have a question. Yes. What's up?
How do you know
Like, how do you write this equation?
How do I know how to write the equation? I look at the scenario. I know I have two different quantities I'm speaking about. I'm speaking about adult tickets and children tickets. I know that they cost a total of $138.25. So I assign variables. X for my children's tickets, X for my adult tickets, Y for my children's tickets. X and Y. So 24.75X plus 16Y is equal to the total cost of $138.25. And I repeat the process on the bottom. Once again, adults, children, total. Okay? Any questions on this? And yeah, I understand it is time consuming. It is a time consuming task to write the system, solve it, and solve it. It's not so much, I'm not going to say it's not difficult. The reason it does become slightly difficult is because there are so many different areas that you could make a mistake. And if you make one mistake here, everything else is wrong. You can even do all this right. If you substitute it in wrong or multiply wrong, everything's wrong. There's so many places you can make an error here. You have to be so careful. All right, we have this written in?
No.
No? Yes? Yeah, go ahead.
Oh, it doesn't
That
work.
would be mad. I thought they called it on pages now.
All right. All right. Last thing that we have to do is solve special systems. Now, no new mathematical tricks here. We just need to understand that so far to this point, whenever we solve something, we've always gotten a coordinate pair as an answer. And that coordinate pair corresponded to an intersecting point on the graph. We're not always going to have that. When we have an intersecting line, that's known as one solution. We will not always have systems that have one solution. Just like in Module 7, I solved equations that had one solution, but I also solved equations that had infinite solutions or no solution. The same thing will happen here. When I solve this system, I just want you to look at this graphically, we'll talk about algebra in a second. When I solve this system and I graph both lines, you need to write this at the bottom. I notice that they have the same exact slope, but I have different intercepts. Write that down on your paper. When I graph those lines, if they have the exact same slope, but they have different y-intercepts, what does that mean? They're parallel lines. Will parallel lines ever get closer to each other? No. Will they ever get farther apart?
No.
So then the question is, if I have two lines, these lines have the same slope, they cross the y-axis at different places, will they ever touch each other?
No.
So that would be a case where you have
No solution.
no solution because they are parallel lines. Parallel lines have the same slope but different intercepts, and there will never ever be a solution. Now here, I graphed two lines. Here I graphed two lines. Here I graphed
One line.
wrong. I graphed
Two
lines here.
But they have the same
watch,
slope
they
and the
have
same intercept.
the exact same slope and the exact same intercept. If I were to graph both of these lines, here's what would happen. I would graph one line, then when I go to graph the other one, it would be the exact same thing. That means that these lines are touching each other for ever, which is another way of saying infinity. If you get the same slope, write these terms down, same slope, same intercept, that means that you have the same line. That means that you will have infinite solutions. There's no new math involved here. It's just identifying what happens when we don't have intersecting lines. This is what it looks like graphically. Write that down so I can show you real quick what it looks like algebraically. We got this?
Yes.
Okay. Algebraically. I'm not going to solve this one because we know that this one is one solution, but I do want to ask you a question. Can I solve this right now?
No.
Yes.
No, because it's not in.
Y equals mx plus b.
It's in y equals mx plus b form, but it has to be in standard form. So before I could solve this, I would have to rewrite it. It would be x plus y equals 4, and 3x plus y is equal to, what's over here? 0.
Mr. Wilson,
You're
Mr.
missing.
Wilson, you forgot the x.
That's like a G
Thank you.
pi.
Negative 3x, I know, it's like a weird looking like.
No.
Hold on, one. What about the x?
In the x is negative.
The x is not negative. That's negative. When I move it over, it becomes positive. X plus y equals 4. That's good. Just the bottom one. 3x plus y equals 0. Then I would go in and solve. But we're not going to. If I did, though, it would give me a coordinate pair, one solution. I want you to see, I'm going to write this down here, and I want you to take a look at it, and I want you to tell me if something doesn't strike you as very, very wrong here. Look at that, and tell me if something strikes you as very, very wrong there. Let everyone look at it. What's wrong, Ms. Vega? I have a double inverse. I have an inverse here, and I have an inverse here. Let's examine what happens in this situation. What happens to the x's?
Cancel.
They will cancel out. Boom, boom. What happens to the y's?
Cancel.
They cancel out. What's left over here?
Nothing.
Nothing. How do we write nothing?
0.
Zero.
Okay, so I have 0 over there. What is negative 2 plus 4?
2.
2. I have 0 equals 2. What type of statement is that?
False
It's a
statement.
false statement, and when I get a false statement, what type of solution is that?
No
Solution. False statements give you no solution. Should you ever solve an equation and the x's and the y's cancel, that's a false statement. You get no solution. One last problem to go. 2x plus y equals negative 2. And then I get 4x plus 2y is equal to negative 4. Okay. Let everyone write that. And then here's the question. Do I have inverse coefficients here? Yes or no?
No.
No. So we start looking at the x's. Does 2 go into 4? Yes or no?
Yes.
Yes. So the question then, I have a positive 4 here. What do I need on the top?
Negative.
Negative 4. What can I multiply 2 by to make it a negative 4?
Negative 2.
Negative 2. So I'll multiply the top equation by negative 2. And I'll do my rewriting down here. I have negative 4x minus 2y is equal to 4. I write the other equation. 4x plus 2y equals negative 4. After I do all my multiplication and I write these, I want you to take a look at it and tell me if you don't see something here that's super wrong.
0.
Triple.
I have a triple inverse. I have an inverse, an inverse, an inverse. What that means is this. What happens to the x's? What happens to the y's? Nothing's there. What happens to the 4? What type of statement is that?
Zero.
That's true. And when I have a true statement, I have infinite solutions. If everything in the equation cancels out, that's infinite solutions, Babaloo, and that's it. That's the easy stuff. Any questions on this? Any questions at all?
This is only a homework.
All right, so